Hello, this is Ms. Hobbs with Washington High School Physics using the CPO Science PowerPoint information for talking about electricity and specifically parallel circuits. So far we've talked about open and closed circuits. We've explored circuit diagrams. We've also understood Ohm's law with the relationship between voltage or electrical potential energy, current, and resistance, and what those direct and inverse relationships are. And in the previous video, we explained series, and we're going to contrast that now with parallel circuits. In series circuits, they were all in a direct line, so the same current ran through them, and there was a voltage drop after each time it passed through a resistor and work was being done and a loss of power. So parallel circuits are kind of the opposite of that. So with parallel circuits, the current can take more than one path. In series, it had to go through everything. With parallel, it divides. So originally, when the current comes out, it comes out as 3 amps. Okay? And then as it hits this point, 1 amp splits and the rest go to 2 amps. Okay? And then here, it breaks off, 1 amp goes through, and then 1 amp goes through here. So what happens is that there's always 1 amp of current going through each of the bulbs. So the bulbs have a consistent current. Okay? And then as the result, the amps rejoin, the current rejoins, and you have the same current going in as the same current going out. Okay? And then the circuit diagram is showing this happening here, where you've got the resistors and you've got the branch points going on. So Kirchhoff's current law. Okay, we've talked about Kirchhoff's voltage law with series. Kirchhoff's current law is what's happening now. So all of the current entering a branch point must exit again. So basically they split off and then they have to rejoin. So the currents are going to, split off currents are going to add up to what the original current was. And again, another diagram that talks about what's happening there with the current splits. Okay, so with voltage in parallel circuits, the voltage is the same along a wire, then the same voltage appears across each branch of a parallel circuit. So they're each getting the same amount of electrical potential energy. So you'll notice with a parallel circuit, the lights, instead of getting dimmer after each pass through, actually stay the same consistent color, the same consistent brightness. Okay? And then you've got another circuit diagram. Now notice the situation. With series, the resistors were all along the same line. In parallel, the resistors have a split or a branch between them. Okay, so with resistance, adding resistance in parallel provides another path for current and more current flows. When more current flows at the same voltage, the total resistance of the current must decrease. So by splitting it up, you actually decrease the amount of resistance by an inverse relationship. Okay, so you have less resistance, which is helpful because that can allow a different amount of voltage to go through. You have a same amount of voltage. So each branch works independently. So if this one goes out, this is still going to stay through. This is still a complete circuit at that point. Likewise, if this goes out, all the current will travel through to this bulb. So it allows a backup plan. In a series circuit, adding an extra resistor increases the total resistance of the circuit. In a parallel circuit, more current flows so that the total resistance decreases. So series, you're adding more resistance. Parallel, you're actually decreasing the amount of resistance. Okay. So here is an example of a parallel circuit of 2 bulbs with different resistances. And here is the circuit diagram that shows what is flowing where. Okay. So you've got a resistance of 3 ohms here and a resistance of 6 ohms here. Okay. You have 3 volts before and 0 volts after, so you have no electrical potential energy after that. So you wouldn't be able to light up another bulb over here at this point. Okay. So what's happening here is you have 1 amp of current going through this one and 0.5 amps of current going through this one. And so what happens is you still can get a difference in the light bulb brightness, but the resistance is different, and the resistance is what's causing that difference. And then you've got the parallel versus series combination. So series, same current, parallel, same voltage, and Ohm's law works for both of those. Okay, so series has got to share all the energy, voltage you get each energy. Current is the same in the circuit. Branches can vary with the same circuit. You add up the total branch currents to get the total current. And then resistance increases as you add it in series, and resistance actually decreases in an inverse relationship because the current increases. And then you've got a short circuit. Short circuit just allows the current to flow through the easiest path. So it's not going to branch over here. It's much easier for it to go over here without doing any work. And that way you've got energy flowing with no work being done. Work ends up being done, but it ends up heating up instead of lighting a light bulb, and that's where you get electrical fires. Okay, so if you turn on too many appliances in one current at the same time, the circuit breaker or fuse cuts out the current. If that doesn't happen, you have fires, appliance fires. And the wire will then get hot because there's so much current flowing through it. All right, that is the difference between series and parallel circuits. Thanks. Hello, this is Elizabeth Hobbs, and we're going over how to use Screencast-O-Matic, and it's very easy. Let me click